Hello guys and welcome back to my channel Interview with Bunny, and let me welcome you to the third video of this playlist on graph. So in our last video we have discussed thoroughly in detail that how a complex data structure such as graph can be represented in the computer with the help of few basic representation techniques. So if you have not watched my previous video, I would highly recommend you to go to my previous video and watch that first so that you do not miss any concept from there. So just to give you a quick recap, a graph can be represented in three ways. One is the adjacency list, one is the adjacency matrix, and another is the edge list. And on our last video, we have also discussed that among these three types of representation, which one you should prefer during solving any problem during your technical interview. So if you have missed that concept, please go back to the previous video and watch it again. So today in this video, we will start with the actual coding on graph. So far in the last two videos, we have only discussed about the theoretical aspect of the graph, means what is an edge, what is a vertex, and all the concepts that are related to the graph, but we have not written a single line of code on graph. But today, and from today's video, we will start with the actual coding in Java, and we will see how easy it is to solve any problem. So without wasting much time, let's get started. But before that, if you like this video and if you found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my channel and you are always ready for your next interview. So let's get started. So as we were discussing, we have three ways of representing a graph in Java language. One is the adjacency list, another is the adjacency matrix, and another is the edge list. But as we have discussed in the earlier video, adjacency list is the most important form of representation when you are solving most of the problems during your technical interview. So today in this video, we will first try to write the Java code of representing a graph using this adjacency list concept. And also if you remember, I have mentioned that our adjacency list concept can be implemented in the two ways. One is by using a list of lists and another with the help of a hash map. But in this video, we will be solving with the help of the hash map. And I hope you remember that why I have given the preference of hash map over list of list, because of the fact a graph might not start with a zero-based indexing. For example, in this case, the graph shown over here you can see the edge starts with a 0, which means that it is following a zero-based indexing. So if you are using a list of lists, it will be easy and straightforward approach to implement it. But in case this graph doesn't start with a zero-based indexing and the values start from 1 or with any arbitrary number, it will be very difficult to maintain that in an array list and it will be meaninglessly complicated. So we will be implementing a hash map where the value of the node will become our key and the values attached to that key will be the connected nodes. So without making things much more complicated, let's start with implementing this algorithm and we will see how easy it is to implement it using the Java language. So let's get started. So to implement this graph in Java, we are simply using a basic code editor that is simply a browser supported one. We are not even using our IntelliJ over here. So feel free to use any code editor that you are comfortable with. So let's get started. So here if you see, we have a main block and we have a hello world class over here, and we will start with the graph implementation from the scratch. So to represent this graph, we will simply use the concept of a hash map, and let's see how to implement. So first what we'll do, we'll simply create a class called as graph. So we'll create a class called as graph, and within this graph, we will have to create a hash map where the key will be the value of the node and the value part will be the list of nodes that a single node is attached to. So let's see how to implement that. So we'll create a map where we will be having an integer as the key and we will be having a list of integers which are nothing but the connected nodes. So let's name this hash map as adjacency list. So now let's create a constructor for this graph class. So what we'll do, we'll create a constructor where we will pass a value as v, which means the number of vertices or the nodes that are present in the graph. So that you have to declare it at the very beginning, but that is too optional. So we'll simply pass a value as v, which is number of vertices or the nodes over here. And here within this constructor, we have to first create the object of this adjacency list. So let's create it. So here if you see, we have created a hash map object. So until now what we have created a simple hash map where we have a key and a value, and the key is nothing but an integer and this value is an array list. So this is our graph object, which is nothing but your adjacency list. Now, as a first step, what we have to do, we have to initialize this adjacency list object. So here, if you see, we have passed the value as v, which is nothing but 5 for this case, means the number of node over here are 5. So we will be passing the value 5 in the graph constructor. And with the help of this value, we will first create an empty hash map over here. So let's create an empty hash map over here. So we have created an empty hash map, but this step is not mandatory because here we are simply initializing the values over here. I will show you in the next step that how you can also omit this thing. So until now, what we have done, we have created a hash map, and here we have created some empty spaces, and here we have initialized the value with 0 to 5, which is nothing but 4. Since here you can see we are starting with a zero-based indexing, so here the key starts from 0. But if you want that your graph doesn't start with a zero-based indexing, you can also modify this program accordingly. I will also show you how to do it because this hash map will be flexible enough to implement it in any form you like. So until now, what we have done, this is the key object that we have defined, and here we have defined some of the empty array list over here. Now, as the next step, what we have to do, we have to identify the connecting nodes on which the node 0 is connected to. For example, here if you see, this is an undirected graph. And here if you see, the node 0 is connected to node 1, node 3 and node 2. So these are basically the 3 nodes that are neighboring to node 0. So somehow we have to write the code so that we can represent it over here. So what we will do, we will create a function called as addEdge, which will define the 2 connecting nodes and the edge associated within themselves. So we'll create a function called as addEdge, and here we will pass 2 values. One is u and another is v, which means that the node u is connected to node v. So here in this case, for the first call, which we will implement it very soon, you'll see how to do it. Just understand that on the first call, we will pass 0, 1. Here 0 is nothing but the u and value 1 is nothing but the v. Means we are telling that there is an edge that is there in between the vertex 0 and vertex 1. So this is the representation of what we are trying to implement. Now, as we have discussed in our earlier video, the way the adjacency list is implemented is this node 0 should have all the neighboring nodes over here. Means all the neighboring node means 1, 2 and 3 should be part of this adjacency list. So with the help of this addEdge function, we have to put this value in the array list. So let's see how to do it. We'll write adjacency list dot get of u dot add v. Means very simply what we are doing, do not think it as a graph, think it as a hash map. So since it is a hash map, we are telling that get me all the existing connected nodes for this node u, and within that list add the new vertex that we have got, that is v. So on the very first call, when we are making this call, adjacency list of get of 0 will return an empty array list over here. So it is basically an empty array list for the first call, and within that we are adding a new value that is 1. So what we are doing, for the key 0, that is the first node, we have added the first node that is 1 over here. That is what we have implemented right now. Now the next step that you have to remember it, this is basically an undirected graph. Means this have a duplex connection. Means we can travel from 0 to 1 and 1 to 0. So as we have discussed and understood in our last video, that for both the instance, means for the value 0, we have to represent the 1 in the array list, and also for the 1, we have to also represent the 0 over here, which means that we have to add in the 2 location of the hash map for a single entry of a particular edge. So what we will do, for the node 1 also, we will insert the value 0. So let's see how to do it. So what we'll do, we'll simply copy the same line over here, and instead of u, here we will write v, and here instead of v, we will write u. Just the reverse, means it's a bidirectional connection. So I think this is clear why we are updating the two nodes in the same adjacency list during this implementation. And remember this fact. This is what you have to implement in case of undirected graph. But in case of directed graph, where there is only single way of communication, if we are writing graph of add age of uv, means u is connected to v. At that time, you do not have to update both the nodes of the same hash map. Rather, you have to just update this u node. So what you have to do? You have to simply write down only one index, that is this one. Means only u is connected to v, not the vice versa. Means v is not connected to u. So I think this is clear to you why we are implementing this add age functionality like this. So as of now, since we are trying to implement this as an undirected graph, we will comment out this section. Means we have a bidirectional connection right now where u is connected to v and v is connected to u. So we are already 80% done with the implementation. Let's implement one more function that will be helpful for you for traversing, then that is get connected nodes. So let's implement it. After that, we will understand what it actually does. So we'll implement a function called as get connected nodes. And here we will pass the value of the node. And this will return nothing but an array list, which is nothing but a list object. And here what we will return, we will simply return the list of connected nodes that we have for the nodes u. Means that whenever we are making a call that's get connected nodes, means we are asking that what are the nodes that are connected to a particular node. So for example, if we are calling that get connected node of 0, means we should get an array list like this one. Means it should return me this array list. Means node 1, 2 and 3 is connected to node 0. So this is my requirement. And that's it. This is the complete representation of the graph that you need to understand and memorize it thoroughly. Because this is the basic building block of the graph that you need to understand to implement or solve any problem of graph. Because any problem that you solve on graph, this is the first thing, the blueprint maybe you can say, that you have to implement on any of the problem. So this is the basic structure that you have to memorize or understand, and whatever you do, this is the basic stuff that you have to understand. Now since we have implemented this graph class, let's use this class and let's see whether we are able to represent this graph into this form or not. So what we will do, we will simply create an object called as graph. So here, as you know, we are trying to represent this graph. So since we have 5 nodes over here, so we will pass the value as 5. So now our graph object is ready, means we have defined an adjacency list or a hash map. Now on the next step, what we have to do, stepwise, we have to create the graph. And to create the graph, we will be calling the function called as add age. So let's do it. So we'll call as add age. And as we have discussed, here we have to pass our first age, that is nothing but 0 and 1. So we'll pass the two nodes 0 and 1. So here we are telling that within this two node, there is an age associated over here. Similarly, for the next age, what we will do, we will call this function again. And here we will pass the next value, that is 0, 2. Next on this third line, we will do the same thing, 0, 3. So here if you look carefully, so right now we have done till until this point, means the node 0 is connected to 1, 3 and 2. Now let's define the other 3 nodes, that is 2 and 3. So we'll define graph.addAge, and here we will pass 2 and 3. Similarly, we'll do for the other one. So we are done with this two also. Now we will do for 4, 1 and 3, 1. So let's do the other two. 4, 1. So we are completed with this thing. And as you know, this is an undirected graph. So this order doesn't matter because we have a duplex connection over here. So u to v or v to u both are same for us. So we are done with the definition, and that's it. This is the total implementation of the graph class. I hope you are clear. Now let's run this program and let's see whether we have correctly implemented or not. After that, I will show you a small modification or enhancement to this algorithm so that it will be much more flexible to use during your coding interview. So let's run it. But before that, let me import few of the libraries. that is java.util.star or hash map, and let's print out this adjacency list over here. So what we'll do, we'll simply do a printing operation g.adjacency list. So obviously it's giving me an error that this we cannot call a non-static function from a static block. So what we'll do, we'll make it a static class over here, and let's run it one more time, and that's it. So let's analyze this output to see whether we have implemented it right or not. So here if you see, the node 0 is connected to node 1, 2 and 3. So node 0 is connected to node 1, 2 and 3. Node 1 is connected to 0, 3 and 4. Node 1 is connected to 0, 3 and 4. Node 2 is connected to 0 and 3. Node 2 is connected to 0 and 3. Node 3 is connected to 0, 2, 1, 4. Node 3 is connected to 0, 1, 2, 4. And node 4 is connected to 1 and 3. Node 4 is connected to 1, 1 and 3. So see, we have created our graph object over here with just 3 to 4 lines of code. Now I will show you a more optimized way of representing the graph. So if you remember, I have told you at the very beginning, here though we are using a hash map, but here the indexing is starting with zero-based indexing, means we are passing the 0th index over here because our graph is starting with 0. But in case our graph doesn't start with 0, at that time it will be difficult to implement, because what we are doing over here we are iterating a loop from 0 to v, means our first key is starting with 0, not with some arbitrary value that is required. So what we'll do, we'll simply comment out this code. And here, instead of defining the hash map with the zero-based indexing, we will make it unified, means it can start with any vertex, any node, any value. And to do so, we have to just write one line of code, and that is just before adding these two edges in the hash map, we have to dynamically create an array list for that corresponding node. So let me show you how. So here what we'll do, we'll simply write two lines of code, that is adjacency list dot put if absent, and here we will pass u and a new array list. Similarly, we'll do the same for the next vertex, that is v, and pass the next array list. So let's understand what we are doing. We are doing the same thing, but here instead of initializing with the 0 or the zero-based indexing, we are doing it dynamically. Means whatever value you pass 3, 4, 5, 6, whatever, it will create an empty array list for that corresponding key. And here instead of passing as a get u, we will change it to get or default. So get or default, or our empty array list. So believe me, this is not at all complex. So what we are doing it, we are just saving it from a null pointer exception. So means if there is no connected nodes available, means if the array list is empty for a given node, then simply return me an empty array list. Otherwise, simply return me the list of edges that are associated for the vertex u. And that's it. If you run the code, you will see we will get the same output with no change over here. But I will make a small change here right now. This time what we'll do, instead of starting with the zero-based indexing, we will omit these two things. Omit these few lines of code. Means now our graph doesn't start with the zero-based indexing. Rather it starts with 1, 2 and 3, 4. Means our graph have only 4 vertex, that is 1, 2 and 3, 4. Let's run it again and see we got our output. So this is the complete implementation of the graph data structure using the Java. So here if you look carefully, it is having maybe a 3 to 4 lines of code, and we have already implemented this complex data structure in just 3 to 4 lines of code. So I hope you have understood this video thoroughly and you have found this video useful. If you have any question, do let me know in the comment section below. I will be happy enough to help you over there. So just to summarize what we have learned till now, we have learned how to implement a graph in Java language. Now we know that whatever the complex picture of a graph they provide during the interview, you can simply convert it to a hash map and you can simply store it within your computer. Now we have to understand in our next step that how to traverse within this graph. Because right now we simply have a graph object which is nothing but a hash map. But the complexity doesn't end over here, because during the interview, they will be asking you the problems where you have to traverse different nodes of the graph object to compute something. For example, the weightage or some other things, so that we will implement it in our next video. So in our next video, what we'll start? We will start with the implementation of the traversing logic. So just to give you a heads up, there are two ways to traverse a graph. One is the breadth first traversal, that is called the BFS. Another depth first traversal, that is called the DFS. So in the next two video, we will understand in depth that what is a BFS and DFS and how to implement it in real time using Java, so that it be easy to solve any problem. Because believe me, that two logic, that is the BFS and the DFS, are the main key component of solving any problem on graph. Because anything you solve, anything, I'm telling you, any problem you solve on graphs, you have to implement the BFS and the DFS algorithm. So in our next video, we'll start with the first type of traversal, that is the breadth first traversal. So until now, if you have liked this video and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon, so that you never miss an update from my side and you're always ready for your next interview. So see you on the next video, where we will be solving the first approach of traversal, that is the BFS approach. So see you on the next video. Thank you.